Hi, welcome back to Moose and Chemistry. This is the Broglie wave equation of extreme fun, lesson 3. The Broglie wave equation is used to prove wave particle nature of light. We use the formula lambda equals h over m times v. Lambda is wavelength, h is Planck's constant, m can be the mass of the electron, m can be also the mass of the proton. V is the velocity of light, which we're going to use 3.0 times 10 to the 8 meters per second. All right, so let's look at our first equation. If an electron has a wavelength of 5.14 times 10 to the negative 9 meters, what is the percent speed of light it is traveling at? Okay, well, let's go ahead and figure out what we know. Okay, we know that the lambda, which is our wavelength, is going to be 5.14 times 10 to the negative 9 meters. Okay, we know Planck's constant because it's always the same thing. It's a constant, 6.626 times 10 to the negative 34, and that's joules per second, of course. Okay. We know the mass of the electron. Okay, so the mass of the electron is 9.109 times 10 to the negative 31 kilograms. Okay, and we're looking for velocities, which we don't know. Okay, so we're going to take our lambda equals h over mv and rearrange it to get lambda mv equals h, v equals h over lambda m. All right. Okay, I don't like that way that h looks. Let's just make it a little bit cleaner looking. What do you say? There you go. That looks a little bit better. All right, now all we got to do is just fill in the fun numbers. Okay, so v equals Planck's constant on top. Always have to write those 4's over. Likes to drag together for some reason. Of course, you do that, you start making other little stupid mistakes. But there we go. Joules per second. Okay, over, of course, our mass, which is going to be 9.109 times 10 to the negative 31 kilograms times our wavelength, 5.14. Well, someday maybe it'll stop dragging across. What do you think? 1.4, and that's going to be times 10 to the negative 9 meters. Okay, so V is going to equal 6.626 times 10 to the negative 30. Come on, let's do this one right. Oh, yes. Joules times second over, we multiply the two bottoms together, and you get 4.68. Some change here. 4.682026 times 10 to the negative 39. And that's going to be, of course, meters times kilograms. And then we're going to get V equals, of course, 141 519.93 meters divided by 3.0 times 10 to the 8 meters per second. And that's the speed of light, by the way. So let's see what we've got going on here. Our velocity is going to equal 0.0004717, sorry. But you know, we have to times that by what's the percent? So that's in meters per second. So what percent of that is of that light? So you got to times that by 100. And our velocity is going to give me, it's going to be 0.047% the speed of light. Okay, there's the answer to the first one. Okay, let's go to the second one. What is the wavelength of a proton whose velocity is 30% the speed of light? Okay, well, now we're going to take our lambda, and we'll have h over m times v. Okay, so we're going to see what we've got. What do we know? Okay, yes. So lambda is what we're looking for. So we're going to keep this equation. The mass of the proton is 1.67 times 10 to the negative 27 kilograms. And our velocity is 30% the speed of light. Well, the speed of light is 3.0. So to figure that out, you go, we're going to put this over here. 3.0 times 10 to the 8 times 0.30. And that's going to give us approximately 1.5. No, correction. It's going to give us 9 something. So it's going to give us 9.0 times 10 to the 7 meters per second. All right, good. So that's our velocity. So we're going to put that in there now. It's 30% the speed of light. Sorry about that. And now we're ready to actually do the problem. So let's go ahead and clean up a little space here. Get this cleaned up for us, and then we can go ahead and solve the problem. So lambda equals, of course, the Broglie on top. Okay, divided by our mass of our proton, times the speed of light, or velocity. 30% the speed of light, as a matter of fact. Okay, do the math. Almost there. Divide it by those two numbers that we multiplied on the bottom. We are almost home here, guys. By the way, it's 19, right? So lambda is going to be, our wavelength is going to be 4.4085 times 10 to the negative 15 meters. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moosing Chemistry.